Good morning, friends. In the last period, we have studied about the Maxwell's equations. In the Maxwell's equation, we have considered the first equation, that is divergence of dou D is equals to rho, divergence of B is equals to 0. Then also curl of E is equals to minus dou B bar upon dou T, curl of H bar is equals to J bar plus dou D bar by dou T. That four equations we have derived in the last lecture. Now, in the today's lecture, we have to study some problems on the topic number 2, that is a time varying field. In that, first problem we are discuss here, an inductor having inductance. Inductorचा inductance दिलेला आहे. Let us consider a problem and the solution we have. That is, an inductor of inductance is what? Inductor of inductance is 0.5 Henry and carries a current. The current is decreasing at the uniform rate of decreasing current we have given here, 0.05 ampere second, and find induced EMF in that circuit. This is the problem we have. First of all, we have to write the given data. What is given here? Inductor of inductance, that is L is equals to 0.5 Henry we have given. Secondly, we have given that is carries a current. The current decreasing at the uniform rate di by dt is equals to minus of 0.05 ampere per second. This is the rate of current we have given here. And find induced EMF. We have to find the induced EMF here. What is the formula for induced EMF we have? The induced EMF is nothing but what we have, that is E is equals to minus d phi by dt. E is equals to minus into d phi by dt. D phi is nothing but, say, that is L into I. So we have to write that L is taken out. L into di by dt is the formula for that. Now substitute the value. What is the value of L? L is 0. Minus sign is there. 0.5 is there into here. We have given di by dt is also minus 0.05. Multiply these two terms. What we have to say that minus is becomes plus, and 5 5s are 25. And how many digits we have? 3. That is 0.025. This is what we have to say that EMF, it is measured in volts. And this is the answer we have, 0.025 volt. This is the EMF induced in that circuit. In the examination, we have given that the formula is what? E is equals to, basically what we have to say that E is directly proportional to, or E is equals to minus d phi by dt is the formula, and phi is nothing but what? L into I. Substitute that value, it gets that E is equals to what we have, minus into L into di by dt. This is the formula we have to use for finding the EMF induced in the circuit. Understand? E is directly proportional to d phi by dt by using the Faraday's law of electromagnetic induction. E is equals to minus d phi by dt. Phi is nothing but the magnetic flux. Flux having formula is L into I. Phi is directly proportional to the I. Self-inductance, we have to consider phi is directly proportional to I. When L is called as a coefficient of self-inductance, and this can be, we have given here, and rate of flow of current is also given, di by dt ampere per second. Substitute that, it gets the multiplication, and EMF is this one. Okay, now second problem we have given here, that is a circuit consists of a resistance, having a resistance. We have given here, circuit consists of a resistance, that is R is equals to 15 ohm, and inductance is a 2 ampere, and current is falling through the circuit is, say, we have to consider, say, I is equals to what? 2 ampere. The current is decreasing at the rate of, means we have to say that di by dt is equals to, we have given here a minus sign is there, minus of 1 ampere per second di by dt is given. Find the potential difference in the combination, means we have to say that E is we have to find in the circuit. First of all, we have given here, that is a circuit consists of the resistance is 15 ohm and inductance is 5 ampere. Sorry, here inductance is 5 ampere. Inductance is 5 Henry is in series with the five Henry is in series. 5 Henry is in the series with the battery of 20 volt. Is in series with battery of 20 volt. Means we have given here data is insufficient. That is, inductance is L is equals to 5 Henry. Battery of EMF is we have given here. That is, V is equals to what we have, 20 volt. Battery of EMF is we have given here 20 volt. And the current is a 2 ampere. And current 2 ampere. Current is given here 2 ampere. Current is given here 2 ampere. The current is decreasing at the rate of, the current is decreasing at the rate of, we have given here the rate of minus 1 ampere per second. This is what? Minus 1 ampere per second. That is di by dt is also we have given here is equals to, we have to consider say minus 1 ampere per second. This is the data we have. First of all, we have to find the EMF across the what we have to series circuit. We have to know that here resistance, then inductance. This can be connected. A circuit consists of resistance of 15 ohm and inductance is of what? We have to say that 5 ampere. That is say R, and this is say L. It is connected in a series with the battery. Battery is given here. The battery of EMF is considered as say, that is say E of EMF is we have to consider say E is equals to 20 volt. This is the circuit we have given here, and current flowing through the circuit is considered as say I. I is nothing but the current flowing through the circuit. That is also we have given. Means we have to consider first of all EMF across the resistance. That is, this is the EMF across the resistance ER, and here resistance across the inductance is EL. Therefore, EL is equals to what we have to say that is L into di by dt. We have given L. L is what? 5, and di by dt is minus 1. That is equals to minus 5 volt. That is, we have given the inductance of the EMF, and ER is equals to V into I. V is we have given 20, V is equals to IR, na? I into R. I is given 2 and R is we have 5. R is 15. That is equals to what? 30 volt. And in series, when you have these parameters are connected, at that time V combination, your E combination is equals to, we have to say that ER plus EL, and this gets that ER is nothing but what? That is 30 volt, plus into bracket minus 5, and it gets finally that is equals to, we have to say that uh, potential across batteries also we have given. Three parameters are connected. A series a circuit consists of the resistance of 50 ohm, inductance of 5 ohm is in series with the battery of 20 volt. This battery is connected in series with that. This is what? E. This is 20 volt. And this is what we have to say that E. And it negates what? E is nothing but 20. And this is finally what we have? 20, 45. 50 minus 5, 45 volt. This is the combination EMF we have to consider for the circuit. This is the problem we have considered, that is first of all resistance and then inductance and then battery. All the parameters are connected with the big potential difference. This is called as a PD, potential difference. We have to find potential difference across the combination, and the potential difference across the combination. First of all, we have to calculate potential difference across the inductance, that is L into di by dt. Potential difference across the R, that is I into R, and the combinational EMF is equals to ER plus EL plus E, and E is nothing but we have given here. The battery of EMF is, we have given the 20 volt. So these three parameters we have to add it gets that a 45 volt of the battery current can be flowing through the circuit. Okay, the next problem we have one more. Write down all these things, very important book problems. One more problem you have to take on now. Calculate the mutual inductance of the transformer mutual inductance of the transformer in which output voltage is a 20 volt, when current in primary changes at the rate of 5 ampere per second. Current in primary changes at the rate of 5 ampere per second. This is the problem we have given here. First of all, solve this problem. What we have to calculate? Calculate the mutual inductance. Mutual inductance is denoted by what? M. Mutual inductance of the transformer in which output voltage we have given. Output voltage is denoted by a symbol is what we have to say, that say E. That is output voltage E is equals to 20 volt. When current in the primary changes at the rate of, means di by dt is changes at the rate of 5 ampere per second. This is we have denoted by E. What is the formula? E is equals to, E is directly proportional to I is equals to minus d phi by dt. Phi is nothing but m into I. So we have to write that this is a minus of m into di by dt. M into di by dt, where m is called as what? The mutual inductance, and while we have to take in the magnitude. In the magnitude form, what we have to say that is equals to this can be written as di by mutual inductance is equals to E upon magnitude of di by dt, and that is what is 20 divided by 5, and mutual inductance is nothing but 5 4 is 20, that is 4 Henry. This is the answer we have to consider for this problem. That is, we have first problem we have to calculate a self inductance. Then also we have here mutual inductance. Mutual inductance formula is what? E is directly proportional to d phi by dt, where phi is nothing but what? M into I. So we have to write that E is equals to minus d phi by dt is there, and this is minus sign is here, M into di by dt. Using this formula, we have to calculate the magnitude of mutual inductance. So we have to say that M is equals to E upon magnitude of di by dt, and di by dt is nothing but 5 ampere per second. So the answer is what? 4 millihenry. Write down this. Thank you.